Okay, we are going to pick up a little before where we ended last time. We're going to talk about binning data. The whole idea of binning data is to allow for quantitative data to be put into groups. Remember, there are two types of data that we've talked about, qualitative and quantitative. Qualitative talks about some characteristic or trait. So for example, what style of shoes are you wearing? What type of car do you drive? Is it a sports car? Is it an economy? Is it an SUV? Okay. So qualitative is going to talk about things like that. And we the other day discussed that you really can't average those things. You can't add up 3 SUVs plus 2 economy class plus a pickup and get a minivan or whatever it might be. Okay, they are separate, discrete things. The other type of data is quantitative. As the name implies, quantitative talks about a quantity. A grade of A on a paper is qualitative. It just speaks to the overall characteristics of the paper. A grade of 87 on a paper goes beyond just speaking of general characteristics and gets right down to this percentage of the paper is accurate, this percentage of the paper has problems. When you are dealing with these two types of data, you deal with them differently. Okay? If I holler to Daniel, jump in the car, let's go get something to eat, where I'm going to go, what we're going to do is different than if I holler that same thing to Lauren, because they are different people. Different traits, different qualities, da-da-da, and they need to be treated differently because they're different people. Same thing here, qualitative and quantitative data are different and they are treated differently. With quantitative data, what will happen sometimes is that you're going to have a situation where you've got a whole string of numbers. And you may want to take those numbers and put them into little packets that make sense, like A plus, A minus, B plus, B, B minus, things like that. That is what is called binning the data. Binning the data talks about like putting it in separate little shelves or little drawers. One of the things that's illustrated here that's a problem is when you bin data, you want to look at each interval. This reflects an interval of 24, 24, 24. Uh-oh, what's this interval? 25. That's a problem, isn't it? How could you correct that leftmost interval to make it jive with the rest of them? Could we go 0 to 24? No, what's the problem with that, Elijah?
We're just skipping out 25.
Yeah, 25 isn't anywhere then, is it? What you would need to do with this would be to start it at 1, okay, instead, and run it on up from there. When you are looking at data, make sure that things are set up correctly. And it's real easy to accidentally get things off by 1, because on this, oh geez, we got to start at 0 and we got to get up to 25. Okay? No malicious intent, just an oversight. So when you start binning data, you want to make sure that each of the intervals is the same length. Here in this frequency table, you can see now that each of the intervals is the same length, isn't it? Each interval is how long? It's 4 units, isn't it? See that? And from that, we could then take and put our scores in. Well, the 76 is going to go here, the 80 is going to go here, a 78, a 76, 94 almost made it. There's a 98, 77, and right on down the list, and you can compute the relative frequency and the cumulative frequency. Does that make sense to everybody? Are you okay with filling in a chart like this? Okay. This is going to be easy for Friday. It'll be on there. Once you've got things sorted, binned, okay, if it's quantitative data, you can then start looking at things like the relative frequency, and you can use that to create different types of charts or graphs. The advantage of charts and graphs is that they're pictures. Our talked about the other day are really set up to retain pictures. When somebody starts talking about something like a pizza, ooh, pictures come into your mind, right? Round, probably pepperoni, sausage, who knows what on there. But the point is that it brings to mind pictures. The advantage to graphs is they're pictures of the data. They're pictures of a bunch of numbers. When you look at a graph, I don't care where it is, if it's in the New York Times, USA Today, a website, okay, Fox News, I'm trying to pick things on both sides again here, okay, make sure that it has the following. Be sure that there's a title or a caption that explains what's going on. On the vertical axis, make sure that whatever the scale is, it's even all the way. The spacing is the same all the way. They don't change scales and part of it jumps to 2 and part of it jumps to 10 and craziness like this. There should be some kind of a title over here to explain what these numbers mean and tell you how big the numbers are. It might be in terms of dollars, it might be in terms of thousands of dollars, and if it's in terms of thousands of dollars, it should say thousands. Because up the side it may just go 5, 10, 15, 20. Oh wow, we're talking 5, 10, 15, 20 dollars? No, 5, 10, 15, 20 thousand dollars. Oh, that's a little different now, isn't it? Okay. Similarly, along the horizontal axis, make sure that the scale is equally spaced and titled. If those things are missing, I don't even bother looking at the graph or paying it any real value. Okay. It's kind of like I wind up going to various places to speak. Okay, I was out in San Diego a couple of months ago, and you know, when you're in different cities and things, do you have to be careful where you go? Yeah, you got to pay attention. Okay, in Cincinnati, you pretty well know where you want to hang out and where you don't want to hang out, and where it's okay to be at midnight, and I don't want to be there at midnight. Okay, you get the idea. Well, it's the same thing in other cities. Before I go someplace, I'll ask the concierge or somebody at the hotel, and I'll kind of walk by it and look it over and look at what's going on around there, and if it looks okay, pop on in. If anything looks questionable, I just keep on going. The same thing with these charts and graphs. You look around the outside of it. If everything on the outside looks to be in line, then go ahead and take a peek at what's going on inside. If the stuff around the outside looks to be a problem, stay away from it. All right, qualitative data, bar graphs. There's a difference between a bar graph, which is what this is, and a histogram, which is going to look pretty similar to this, and we'll see a little bit later. With a bar graph, it's always for qualitative data, different categories like red, blue, green. And because they're different categories, there is always spacing in between the bars or the different, thank you, or the different categories. When you do a bar graph, be sure that you leave spacing. It shows that they are separate, discrete, unique categories. Okay? If you run across something where people are dealing with qualitative data and they got the bars smashed up against each other, I'm suspicious. They picked the wrong tool for the job. Now, if they picked the wrong tool for the job, hey, here's one for you. Your car's not running right. You take it to the mechanic. And the mechanic says, oh man, one of the fuel injectors is clogged, and pulls out a full-size sledgehammer. Are you going to pop the hood on your car? Good. I'm hoping you're starting it and leaving. That's the wrong tool for the job, isn't it? I don't know what a fuel injector is. Okay, your windshield's dirty. And they come out with a sledgehammer. Here, let me clean your windshield. Wrong tool for the job. Hopefully you're on your way out. Okay? Same thing here. When they choose the graph, make sure it's the right tool for the job. If it's the wrong tool, question the mechanic. Does that make sense? Nice thing about this bar graph, and I really like this, is that for each category, for example, A's, if you look to the left, you can see how many people got that grade. And if you look to the right, you can see what percent of the class it is. So it is very reasonable to have information on both vertical axes. It's okay to crunch extra information in there. It's not what's commonly done, but it's not out of reason either. Another very common chart to use with qualitative data, remember we're working qualitative here, so this would be A's, B's, and things like that, okay, is a pie chart. They're kind of fun because you can get different colors involved, and it's a little bit nicer than just straight black vertical columns. But what you got to be careful on a pie chart are a couple things. First, take a look around and make sure that your percentages add up to 100. If they don't add up to 100, there's something wrong. Somebody's getting out the sledgehammer to clean your windshield. Okay, there's something wrong here. This doesn't look good. Second thing to make sure of is that the width of each piece of pie looks appropriate to the percentage that it represents. So for example, this A, which is 16%, should be twice as wide as the F, which is 8%. Here's a real good question. Always appears on quiz, test, final exam somewhere, sometimes a couple of times. For the A's, what should the measure of the angle be? How many degrees should that 16% be? Well, the nice thing here is, if we go back a couple, we could look at the A's and get the relative frequency, couldn't we? That's at 16%. This percentage right here is the relative frequency. To get the angle, what you do is you take the 16% converted back to a decimal, and you multiply it times, how many degrees are there in a circle? 360. Why 360? Why not 350? Wouldn't 350 be easier to work with? Or for that matter, why not 100? I mean, why 360? That's kind of a weird number, isn't it? You know where that came from? Back in the good old days being a few thousand years ago, one of the things they were trying to figure out is, gosh, it seems like about the same time every year the leaves turn yellow. About the same time every year the grass starts to pop back up. You keep getting the same season over and over and over again, don't you? I wonder how many days it is about from fall this year to fall next year. About how many days is it from fall one year to fall the next year? 365. We know this because we got a more accurate way to measure things, don't we? Back in the old days, they didn't have satellites and all this other cool stuff and the computers, and they kind of guesstimated, and they guessed that a year was right about 360 days. One complete cycle, 360 days. That's where they get to 360 degrees. If they would have known back then that a year is 365 days, how many degrees would we have in a circle now? 365. That's where the 360 comes from. Okay, so we take the 0.16, multiply it by the 360, and we're going to get about 57.6 degrees. So this angle here should have a measure of about 57.6 degrees. Does that make sense? Okay. What's the measure of the angle on the B's? What's that angle measure? Well, let's see. What's the relative percentage? 28%. So you're going to take 0.28 times 360. Yeah. And it's all downhill from there, isn't it? Works out to be 100.8 degrees. So about 101 degrees. With pie charts, you got to be careful. And we're going to talk more about this as we get into 5D. But with pie charts and any other chart or graph that you're looking at, there are some things that are stylish and they look more interesting, but they're deceptive. And it may not be that the person's trying to be deceptive at all. They're just bored of having these flat disks. So on Excel, it's real easy under pie charts to pick this disk. You just click a radio button. If you click a different radio button, it'll kind of lay the disk a little bit over on its side, and it'll show you an edge as well, kind of like looking at a coin laying on a table. There's a problem with that particular view, and the problem is you're going to have some of the slices that are closer and some that are further away, perspective-wise. Do I look taller if I'm standing 2 foot from you or half a mile from you? 2 foot, right? A half mile away. Gosh, she's only about that tall. It's all because of perspective. On a pie chart, when these things are created on the computer and they're kind of rolled over on their side, two things can happen. One, the slices that are closer to you look bigger than the exact same size slice on the back side of the chart. Visually, the one looks bigger than the other, even though they represent the exact same percentage. That can be deceptive. A second thing that can be deceptive is along this front edge is more space, and it's usually a different color, so your eye is somewhat drawn to it. And what will wind up happening is when you look at this, your eye will take into consideration this whole big chunk, and it drops down and also picks up the area along the front edge. So optically, it picks up more area than is really there. It's not as exciting or as cool, but the best way to do a pie chart is flat. Now on this one, they tried to dress it up a little bit by putting some shadow around it. That's fine. Everybody get the same amount of shadow all the way around. Okay. Another thing that can be really intriguing is the actual way they treat the data. For example, 8 leading emitters of CO2. If you look at the total amount of CO2 produced by country, the number one producer of CO2 at the time this information was published was China. But there are several ways to look at this. One is the total amount that the country produces. That's his first column. The other is, another way to do it is to break it down to, well, gosh, how much CO2, how many tons of CO2 is this per person? And it gives very different results. Once again, it's a bar graph. Is that appropriate for this data? Well, yeah, that's what's up there, Chuck. Okay, let me rephrase it. Why is it appropriate for this data? Because the categories on the x-axis are qualitative. They're countries. They're separate, discrete packets. So you want to separate them with their own bar. If you take a look here, who's leading in CO2 emissions? China. But presented a different way, when you don't talk about total, but you talk about CO2 per person, what happens to them now? Doesn't look so bad, does it? One of the things I have a good time with in this class is, as we move into chapters 6 and 7 and stuff, we're going to get into some stuff with statistics and data. And I enjoy going through the FBI records. You can get into them? Yeah, did you know you can get into them? They're public domain. All you got to do is go online. Jump in a search engine, click in FBI records for and whatever it is you're interested in, and away you go. There are a lot of things that feel one way but are actually very different than the way that they feel. For example, back in the 1940s, do you think people really worried about their kids being kidnapped? They'd let the kids run down to the playground by themselves, play all day at the playground with the rest of the kids, and then by themselves come home. And they never give it any thought. A couple years ago, I read a story, saw a story, I don't know if I read it or heard it online or in the radio or whatever. Two parents, okay, were brought in for child endangerment because they let their 10-year-old walk a couple of blocks through their neighborhood down to the playground without a parent along. Just a regular old neighborhood. And they got in all kinds of trouble. They had to bring in an attorney and thousands of dollars and all kinds of stuff because they let the kid walk by themselves down to the playground. Is it really that much more dangerous now for children to be out running around? Now, I'm not talking about in a war zone in who knows where. I'm talking about a regular old neighborhood, okay, middle-class neighborhood. I'm not talking about a really shady part of New York City or Chicago. There's the one that's got some shady parts to it, okay? I'm not talking about that. I'm talking about a middle-class neighborhood. Is it really that much more dangerous now where they got to be dragging parents in and involving attorneys and stuff and putting people in jail? Do you know the kidnapping rate now is exactly the same it was in the 1940s for children? Exactly the same. Does it feel like that? Feels more dangerous, doesn't it? Why? Because on the internet and the news, it used to be the news was on at what, 6 in the morning and 5 in the evening and 11 at night? Now, all day long in Criminy, what's popping up on these things all the time? Late breaking news. Okay, a child in Australia is bitten by a koala bear. Really? Okay. Oh my gosh, I better bring my kids in. There might be a koala bear out here somewhere. Okay? It just feels different. It isn't any different. Actually, was it safer in the 80s or now in the U.S. as far as murder rates go? Safer now. We'll see that here in a little bit. Here's another weird one. I'm just throwing stuff out. These are just facts. I'm not saying one side or the other. Okay? About how many people were shot with handguns last year in the U.S.? Shot, killed. About 2,500. Okay? Of that 2,500 people who were shot and killed, how many of them were shot by a person who had that gun illegally? 98%. 98% of these were people who were breaking the law, even having the gun. Now, there are a lot of folks pushing for stronger gun laws. Is that going to affect that 98%? No, because are they worried about the laws anyway? No, they got it illegally. Oh, that's interesting. Here's one, 1 million. Relates to guns. Any idea, in the U.S.? Any idea what that number relates to? Yep. The number of crimes that were stopped or people who were protected because they pulled their gun out last year. Have you ever seen that statistic before? Did you even know there was such a statistic? And this is obviously low because there are cases that aren't even reported. These are the ones that were reported. Interesting. Okay. That one's pretty straightforward. Now, look at this graph. Shop around the outside. It has the title, Exam Grades. Frequency, okay, this is how many times that particular grade was scored. Oh, the scores go 70, 75. Okay, so we must be talking about the exact grade on the paper now. Notice I looked all around the outside. Now I'm going in. Hey, take a look at this. The columns are not separated. They touch each other this time, don't they? The difference is this data is quantitative. These are the exact grades that people got on it. 76, 83, 94, whatever it might be. And do the grades go from 76 to 77 to 78? Yeah, they flow right from one to another. Okay? So in this situation, you can go ahead and you can list the scores. It is quantitative data. And as the scores were listed, they were put into groupings. If you just did it, yes, sir?
Was pie chart quantitative or qualitative?
Qualitative. Yeah, thank you. Pie charts are qualitative. I hope I didn't write quantitative there, did I? I didn't write anything there. Okay, these are qualitative. Yeah, thank you, Parker. Okay, so there we are. Get back to where we were. There we are. Okay, so what's been done in this case is the scores have been binned. They've been put into groupings. And the number that's in each grouping is listed. There are a couple of ways to reflect quantitative data. One is with a histogram. It's very similar to a bar graph, except the columns touch because it flows right from one into another. Okay. Another way to reflect quantitative data is with a line chart. Now, if you're doing a line chart, notice where the data point is placed. In the interval from 95 to 100, the data point is not put at 95, it's not put at 100. Where's it put? In the middle, isn't it? Same thing for the 90 to 95, it's put in the middle. The 85 to 90, So if you're doing a line chart, and you have binned data, whatever that interval is, you put the dot in the middle, not on one end of the interval or the other. Does that make sense? Sometimes what will also happen is you'll have both the histogram and the line chart on the same graph. Okay, let's see. This is ages of Academy Award-winning actresses. Okay, number of folks, 10, 20, 30, 40, and age at the time of the award. Okay, so this is the age of people. Okay. Hey, if you've got a favorite actress, if she hasn't won an award by 50, what are the odds are she's going to get an Academy Award? Yeah, slim to none, right? Because look at there, it basically just drops off the end. I don't know what the 60 to 70 is, maybe a couple people in Driving Miss Daisy and a couple of other movies like that. But look at there, where do most of the awards go? In the 30-year-old grouping, don't they? Followed very closely by the 20-year-old grouping. After that, it kind of falls off pretty fast. Are you okay with this? Not the ages that they get them at, but the way that you can impose one graph on top of another. There is a specific type of quantitative chart called a time series. A time series can be either a histogram or it can be a line graph, either one. And what makes it a time series is that on the x-axis, the data on the x-axis is time. Oh, that's pretty clever. Now, remember before I mentioned that the the murder rate in the U.S. has dropped considerably from the 80s. One of the things that I want you to get used to is when you're looking at a graph, don't just take my word for it. Look at what's going on. Look at the actual numbers. Homicides per 100,000 people. At 10, this means that across the country, on the whole, out of every 100,000 people that you got together, 10 of them are going to be killed, murdered. Okay? 6 is down here. How has the homicide, and I know this only goes out to 2012, but it's still staying down, gone down a little bit lower even. Okay. It's down, well, even here it's down close to 5. It's still around between 4 and 5. How does the homicide rate now compare with some of the high points? It's about half of what it was, isn't it? One of the aspects of a graph that you want to study carefully is the vertical scale, because you can make things look really dramatically different that are not dramatically different. On this, you're looking at a difference between 4 or 5 and 10. Okay. If we were looking at something on a diet, I'm just trying to pick something where the numbers could be smaller. Let's say here is 1, 2, 3. But these are ounces lost. And the graph could shoot way up like this. We could even spread them apart further to make that look really tall. But the thing to be mindful of is, even though this looks really tall, is there really that much difference going on the actual scale? The answer there is no. What people will sometimes do on a graph, if they're trying to deceive you, is they will shift the scale markedly one way or another. If in this case they're trying to say, whoa, there's something really big going on, spread it way out. What if they're trying to hide a problem? Okay, let's do something like spending, City of Cincinnati. And the city council is trying to hide that they've gone crazy on spending. On the side, are they going to make the scale tick marks tiny numbers so that you can see minor changes, or are they going to make the tick marks really big numbers so that it takes a big change to get any jump? They're going to use big numbers. Okay, so like this might be $10 million here, and $11 million, well, let's say $20 million here, and $30 million here. Those are big jumps. And they're going to say, well, gosh, look, it's things are staying about the same, and it doesn't look like that much change there. But in reality, I don't know why that extra little diving board there on the left side, it's almost doubled, hasn't it? Based on that, I'm not saying, I don't know what it really is. Okay, it has been going up. But you can hide things in a graph too by the way you choose the scale. So you as the consumer need to be careful to think about what that graph is actually telling you. Okay? All right, let's see if we can, without a whole lot of issues, get into 5D, which is really a continuation of what's going on here. In 5D, what we're going to start doing is we're going to take a look at some different types of graphs that have been pulled off of various websites and out of newspapers and things like that. Sometimes the graphs, even though they're a little different, are pretty neat as far as illustrating what they're trying to prove or suggest. on this graph, it includes multiple bar graphs. How do I know these are bar graphs and it's not a histogram? They're not connected. So the first thing to ask is, based on these categories that we have, is this qualitative or quantitative information? It's qualitative, isn't it? You can look down through the various levels of education. That's qualitative. So a bar graph makes sense, not a histogram. And one of the things that's kind of intriguing with this is, now keep in mind these unemployment rates are from '08. These numbers are way down from what they were. Way down. Okay? What trend do you see in unemployment as you move along in education? It goes down, doesn't it? And income-wise, what trend do you see as you move up in education? It goes up. So what they were trying to, from the Bureau of Labor Stats, by putting a graph like this together, what are they trying to tell people? Yeah, get an education. Now, one of the things that's not on here, that really needs to be on here somewhere, is trades. The problem with trades is it would be about like this and about like this. It kind of blows the curve, doesn't it? What do I mean by trades? Yeah, going to a vocational school for things like plumbing, welding, electrical, okay, automotive. Especially the plumbing, welding, and electrical, those people kill it. A friend of mine is a welder. Okay? He went to school for no more than 16 months. He makes more than I do. And he works less hours a week than I do. Okay? Makes a lot more than I do. And sometimes there'll be a couple weeks where there's nothing going on. He's got a couple weeks off, and he still makes more a year than I do. Okay? So if you're thinking, gosh, I don't like the way my budgets are looking. I'm only making I'm only making $30,000 a year. Okay? There are some options without going for a PhD. Okay, so this is one, multiple bar graphs. This one's pretty cool. I like this one because of the fact that it breaks down the information into discrete packets so you can see exactly what's going on and what the overall consequence is. Okay, so let's read and see what this has to say. Average estimated undergraduate budgets, this is for '08-09. This is the undergraduate budget, okay, so it's going up evenly by 5,000s. And it's in 4 different groups. 2-year commuter, oh, that's us. 4-year public, that's main campus, UC. 4-year public out of state, that's if you go to Indiana University. 4-year private, can anybody think of a private university? One that you may recognize. Oh, yeah, well, yeah, there is that. The cool thing to notice here is, in the legend, that's that little box with the different colors, it explains to you what the green and what the orange and the red and the bluish gray and the dark blue all mean. Take a look at all 4 of those as far as other expenses. That's things like shampoo and socks and stuff like that. What do you notice about the other expenses at all 4 levels of educational experience? They're basically the same thing. Okay, socks cost the same anywhere. The next thing, transportation. What do you notice about transportation in all 4 categories? Basically the same. Books. Books are going to be different, aren't they? Well, that's this little red thing. Huh. Books are within about 20-30 bucks of each other, regardless where you go. Now, the next one is room and board. Wherever you are, you got to pay for food. Here's this one, this one, this one. It gets a little bit bigger, doesn't it? Where's the big difference lie in the four different costs? Tuition. Okay? That versus that for the same class. There are several factors that prompted me to choose here. I didn't come here because I had to. I had 7 or 8 job offers that year. A couple of them were Ivy League stuff like Harvard. Okay? I didn't come here because I had to. It was the only place. One of the biggie reasons I came here is because you're getting a really good deal based on the amount of money you're paying on tuition. How much is tuition this year? It's about $3,000 a semester, or about $6,000 a year. You're paying $6,000 a year here. That is compared to elsewhere, that is a good deal. When you go down the main campus, what's it going to go to? $12,000, which still is not bad. But you can get the exact same class here, the exact same class, for half the price, literally. Of course, you can go to Harvard and get the exact same class for a little bit more. Okay, this stack plot, intriguing. First off, how do you read this thing? By the stack, that means you go all the way up to the top of the pile to see what was the total number of deaths. In 1990, the total deaths per 100,000 people was 600. Now, that's for these diseases. Okay, so of every 100,000 people in the U.S., about 600 of them would die from cancer or cardiovascular or pneumonia. One of the things that's kind of interesting here, you see this little blue area? What's that blue area? What disease is that? Tuberculosis. 1900, that was a serious problem. When was the last time you knew anybody with tuberculosis in this country? Really? Not around. Why isn't it around anymore? Vaccinations, right? Okay. Here's one that's kind of interesting. What's this brown area? Cancer. Back in 1900, there was less cancer than there is now. Right? Trent's looking at me like, What I suspect the difference is, back in 1900, Grandma just got sick and kind of skinny and kind of wore out and died on us. Now, they slap her into an MRI. Well, don't slap her in. They put her into an MRI machine and they know what's going on. Back in 1900, they didn't know it was cancer. That's what I'm guessing. Now, diagnosis-wise, they can figure out what it is, which I'm guessing is why the cancer rate has grown. Pneumonia's gone way down, hadn't it? Look how big it was there versus here. Cardiovascular, about the same. Hey, here's one for you. We'll call it quits on this. Measles. Ever heard of that disease? Yeah. Ever been vaccinated? Probably when you were 6 years old. A couple years ago, big issues with measles up in Chicago and out in LA. There's not been measles in the United States in 30 years. How all of a sudden were there measles in just Chicago and LA? Please? People who don't want to get vaccinations. How'd the measles get here to begin with? If nobody has them, how'd they suddenly get here? Somebody traveled with them. Yeah, you know the people coming across the borders unchecked? Do you think the first thing they do is come to the doctor and say, hey, load me up on vaccines and check me to make sure I don't have tuberculosis? That's how they got to Chicago and LA. Stay up on your vaccinations. Okay? It's just kind of interesting because some diseases are starting to come back in the U.S. that were gone. and it's because of folks coming in who are not vaccinated and properly screened medically. Okay. Hey, I'll see you all on Friday. The quiz will cover 5B, 5C. We'll skip 5D on this quiz because we're not done with that yet. Okay? I hope you have a good day.